So the final graph we're going to talk about is what we call our exponential key features. And an exponential curve is basically a curve. But this curve has a limiting value. And that limiting value that we're going to talk about is what we call, basically it's in the form of floor. And that floor that we're going to create is called the asymptote. But the problem with the floor is that you can't touch this floor. You can never touch this floor. So you'll approach the floor. The asymptote means, an asymptote is a line that the function f of x approaches. It approaches, but never touches. So it's going to approach the floor, but it'll never touch the floor. And we look at this particular graph right here, the first one, we can see that it wants to touch this value of -2. It wants to touch that floor value of -2. But it can never touch that floor value of -2. It can't touch this. It's really an imaginary line that's sitting at, it's a horizontal line sitting at y equals -2. And just from like we know already from our x, we can also find the other key features with our intercepts. We can find the x-intercept sitting here at, or the y-intercept sitting there at 0, 6, and the x-intercept sitting here at 2, 0. So we know that our x-intercept is 2, 0, our y-intercept 0, 6. The asymptote, it can't go below our floor. Here's our floor. It won't touch the floor. Because it doesn't touch the floor, well, this is an imaginary line. This is y is equal to -2. Y equals -2 is the floor. Now, the domain. Well, the domain of the graph is an arrow going to the left, like this, and an arrow going to the right, like that. So the domain of this function is all reals. Notice that all three graphs we have talked about, the domain for every graph is all real numbers. The range of the function, though, the range of the function, well, it wants to touch the floor, but it can't touch the floor. And if it's a floor, it has to go up from the floor. So we're going to be above the floor. So we say above, that means greater than or equal to. We're above the floor. So y has to be just greater than this time because you can't touch the floor. -2. Look at the next one. Again, same process. This time we want to find your floor. Let's find our floor value first. And our floor is here. It wants to touch 1. It's right, sitting right, it's writing 1, but it won't touch it. So I have an asymptote sitting at y equals 1. The y-intercept is sitting here at -2. I mean at +2. So that's the y-intercept at 0, 2. The x-intercept, well, the x-axis is actually down here. It's the x-axis. And this graph is never going to go past 1, so it'll never reach the x-axis. And because it never reaches the x-axis, we don't have any x-intercepts here. There are no x-intercepts here. The domain of every exponential is all real numbers. The range of the exponential function, remember, we have a floor sitting here, but you can't touch the floor. And because it's a floor, you have to be above the floor. So we get y have to be above, that's greater than, but you can't touch, so it's just greater than the floor value, which is 1.